In this lesson, you will learn about inequalities. Now, inequalities, first off, is any statement that has a greater than symbol or a less than symbol, or a greater than or equal to, or less than or equal to, or not equal to symbol. So it's anything that's not equal to something else. Now, when you deal with inequalities, there are some properties that we have. First off is the addition and subtraction property. This property says that we can add or subtract the same number to both sides of an inequality, and it will result in an equivalent inequality. So for example, in math notation, we have the statement of A is greater than B. If that's true, we can add C to both sides of the inequality, and it will still be a true statement. Alright, so for example, if we had x plus 4 is greater than 6, and you're trying to solve this. So you can either add or subtract the same thing to both sides, and here we want to subtract 4 from both sides, and that would solve for x to get x is greater than 2. Alright, so the initial inequality and then your answer, those both are equivalent inequalities. And that is allowed, the subtraction of the same number from both sides, because of this addition and subtraction property. We also have a multiplication and division property. And this says that multiplying or dividing by the same positive number on both sides will result in an equivalent inequality. And something different happens when you multiply or divide by a negative number, which we'll explain in a moment. So this property says if we have A is greater than B, then we can multiply both sides of the inequality by the letter C. Alright, or we can also divide both sides by C. So for example, if we had 4x is greater than 12, we can solve this by multiplying or dividing, and here we want to divide both sides by 4, and we can do that to get x is greater than 3. That's allowed because of this multiplication and division property. Now, the only thing that you need to be aware of is that when you divide or multiply by a negative number, you must flip the inequality. So if you had, for example, negative 4x is greater than 12, you divide both sides by negative 4, that gives you x on the left, negative 3 on the right, but when you divide by a negative, or multiply, you must switch the inequality, and in this case it switches from a greater than to a less than. Alright, so the solving of equations and inequalities are basically the same thing. The only difference is when you multiply or divide by a negative number, you must switch the inequality. So here's an example where we must solve this linear inequality. So to do this, we go through the same steps as we would with an equation. When you solve, you must work in reverse order of operations. Alright, so you have to take care of the minus 5 first, and you do that by adding 5 to both sides. Now we have 2x on the left, and then negative 7 plus 5, which is negative 2 on the right. So we took care of the subtraction. Next we take care of the multiplication by dividing both sides by 2. Now we have x on the left, negative 2 over 2 is negative 1 on the right. So your answer is x is greater than negative 1. Now for any inequality, we can also graph, and here we see our number line, and here is the number negative 1. So you've learned in the past that we can graph with an open circle or a closed circle at the different number, and then just shade in right or left. So you can do the same thing, but we can also have another way of doing this where instead of an open circle and a closed circle, we can do a parentheses like that, or a bracket like that. So here, instead of an open circle at negative 1, we can put in a parentheses right here at negative 1, and then you shade in to the right because that is where the numbers are bigger or greater than negative 1. Alright, so it's the same thing you've learned in the past, except here we're using the parentheses or bracket in place of the open or closed circle. Here is a second example, and we're trying to solve this inequality. So this one is almost the same as the one we just did, The only thing different is we have a negative 2x instead of a positive 2x. All right, so the steps will be the same. You want to add 5 both sides first. So we get negative 2x is greater than or equal to negative 2. And then you need to get rid of the negative 2 being multiplied, and you do that by dividing both sides by negative 2. Now you have x on the left, 1 on the right, and then because you divided by a negative, you must flip the inequality from a greater than to a less than or equal to. So now we have x is less than or equal to positive 1. So when you graph this one, here we are at positive 1, and when you have the less than or equal to sign, okay, normally we would do a closed circle, but here, remember we mentioned we're not using the circles, but we're going to be using the bracket or parentheses. All right, so we're going to use a bracket here at 1, and then we shade into the left because that is where x is smaller than 1. So your graph would look like this. Next, we're going to talk about compound inequalities. And this would be two inequalities that are combined with an and or an or. So the inequalities joined by the word or, we can also say that is a union of both inequalities. We put them together. So union meaning put together. All right, so we have here an example of x is less than 5 or x is greater than 10. Now we can write this, by the way, in a different notation. Okay, so we have what's called set builder notation, and we also have what's called interval notation. We'll begin by showing you set interval notation, or sorry, set builder notation, and then a little bit later we'll show you the other way to write this as well. So basically when you write this in set builder notation, we write this in the following manner. So we're going to have braces around each of these statements. The first statement would be x such that x is less than 5. Then put a brace on the other side as well. So you basically take what you had and you put in x, and then this vertical line means such that. So we have x such that x is less than 5. And then or, the symbol we use for or is going to be this capital U. So the U kind of stands for union. All right, so or is a union of the inequalities. So we use the capital letter U for union, or. And then we put the other one, x is greater than 10. So we put braces around it, and we write x such that x is greater than 10. So this would be the same expression as up here, but this is what we call set builder notation. So set hyphen builder notation. All right, so it's just another way of writing the same thing. And we see that typed up right here. So that is an or statement. And then the other kind is with an and connecting the two statements. So and would be an intersection of the inequalities. So it's where both inequalities are true. So for example, here we have x is greater than 5 and x is less than 10. So this one, if you want to write this in set builder notation, we can write it in the following manner. So we can have braces and then x such that x is greater than 5. And then our symbol for and is an upside down or symbol. So instead of a capital U, it's going to be an upside down capital U. So that is your symbol for and. And then x is less than 10, we can write as x such that x is less than 10. And then put braces around that statement as well. And this particular statement, we can actually simplify a little bit. Because if you think about this logically, or if you think of it with graphing even, what we have is x is bigger than 5 and less than 10. So it's going to be between 5 and 10 when you graph. So you shade it in between like this. You put parentheses around it because it's going to be the same thing as an open circle when you graph. All right, so that would be the graph, but A way of writing this quicker with an AND statement, because it's between two numbers, between 5 and 10, we can write this in the following way. We can write this as x is less than 10, and then also put the other part, x is greater than 5, over here. So x is greater than 5, or 5 is less than x. So you can write it as one combined inequality like this, right here. So that would be a simpler way of writing this expression. And we can, for set builder notation, we need to write x such that, and then 5 is less than x is less than 10. And then you put braces around it as well. So this would be the simplified answer to what we had down here. Now let's work through a couple examples where you need to solve some compound inequalities. Our first example is x plus 1 is less than or equal to negative 3, or negative 4x is less than negative 8. So what we can do is, with this OR statement, is we can solve each part separately. So the first inequality, we subtract 1 from both sides. That gives you x is less than or equal to negative 4. The second inequality, we need to divide both sides by negative 4. Now we have x on the left, positive 2 on the right, and because we divided by a negative, we must switch the inequality from a less than to a greater than. So what we have is x is less than or equal to negative 4, or x is greater than 2. So we can leave it like this for now. We could write this in different notation, either set builder notation or the other one called interval notation. We'll explain that in a little bit. But for now, this is okay. And next we want to be able to graph this. All right, so for graphing purposes, we basically, with an OR statement, we'll just put both of those statements, both of those graphs on the same number line. So the x is less than or equal to negative 4. It's going to be a closed circle at negative 4, which we learned that we can use the bracket instead, like that. So we have the bracket at negative 4, and we shade in to the left, because that is where x is smaller than negative 4. And then x is greater than 2, it's going to be a parentheses at 2, and then we shade into the right, because that is where the numbers are bigger than 2. So this is your graph. You just put them both on the same number line. So we said already that we can write this in set builder notation. We practiced with that a little bit. But now we're going to talk briefly about interval notation. So this is another way of expressing the same thing, but it's actually a little bit quicker to write it this way. So interval notation, what we're doing is we are looking at the interval in which we have answers for x. So if you look here at this x is less than or equal to negative 4, this is going to keep going forever all the way to negative infinity. So that part of the statement would go all the way to negative infinity. It's never going to reach it. So you can kind of think of that as a parentheses over here around negative infinity. And then it's going to go all the way to negative 4. So it's going to go from negative infinity all the way to negative 4, and it's going to stop right at negative 4 with that bracket. So we can write that interval in this manner. Parentheses, negative infinity, comma, negative 4, and then bracket. That is this left part. And then x is greater than 2. We start at 2 with a parentheses, okay, then comma, and this is going to go all the way to the right, all the way to positive infinity. And it's never going to reach it, so we use a parentheses instead of a bracket. Because bracket means it comes to an end, it stops right there. But the parentheses means it's going to approach it, but never actually going to reach that number. All right, so this would be how you write it, and then the OR word, that connecting word, we can express with the union symbol, as we discussed. So you can write that in interval notation in this manner, and we see it typed up right down here. And that should be a positive 2. I'm sorry, positive 2. All right, so that's interval notation. And that's with an OR statement. Next, we're going to show one example with an AND statement. So see if you can solve both inequalities on your own, and then you can see if you got it correct in a moment. So hopefully you try this by yourself, and if not, either way we'll explain how to do this. And what you want to do is you want to solve each of these parts for x. So the first inequality, we can begin by subtracting 9 from both sides. When you do that, we have negative 12x is greater than or equal to than negative 108. Solve for x by dividing both sides by negative 12. Now we have x on the left, and then we have positive 9 on the right. And because we divided by a negative number, we switch the inequality from a greater than to a less than. So your answer for this part is x is less than or equal to 9. The other part we can solve as well. We can begin by adding 4 to both sides. That gives you negative 2x is less than negative 8. And then divide both sides by negative 2. That gives you x on the left, and then positive 4 on the right. And because you divided by a negative number, you must switch the inequality from a less than to a greater than. So we have x is less than or equal to 9, and it's greater than 4. So it's between 4 and 9. So I can write this as a combined inequality, where we write x in the middle, and then 4 and 9 on the left and the right side. Then put your less than and less than or equal to symbol right here. So literally, you write this out as x between 4 and 9. So graphically speaking, it's going to be graphed everything between 4 and 9. And then right at 4, we're going to use a parentheses because it has a less than symbol. So there's no equal sign with it. So it's not going to reach 4, but it's going to get close to it. So we put a parentheses there for that. And then the 9 is going to reach the number 9 because it's got the equal sign with the symbol. And so we put a bracket here at 9. So that would be your graph. And interval notation, when you write it in this manner, you basically just write what you see. So it starts at 4, goes to 9. So parentheses 4, comma, and then 9, and then put the bracket around it. So notice that, just basically take what you see with the graph. Parentheses, and then bracket, 4 and 9. Alright, here's another example. We have negative 3 is less than x minus 5 is less than negative 1. Okay, this is an AND statement when it's written like this. And when you try to solve an AND statement, there's two ways you can approach this. So method 1 is you can actually break this apart into two different statements, where you have negative 3 is less than x minus 5. And we see that typed up right here, negative 3 less than x minus 5. And the other statement would be x minus 5 is less than negative 1. So we can solve each of these inequalities. The first one, you have to add 5 to both sides. That gives you x on the right, and then positive 2 on the left. So we have 2 is less than x. The other inequality, same thing. We can add 5 to both sides. That gives you x on the left, and then positive 4 on the right. So we have x is less than 4. And then we could put it back into one statement, where we have 2 is less than x is less than 4. Alright, so that's one method. You can separate, and then at the end put them back together. But the simpler method would be method 2. So method 2 is you just keep the inequality written as it is up here, and we'll see it typed up down here as well. Same statement. And then what we can do is solve for x, just like you would in a regular inequality. So here we need to get rid of the negative 5 by adding 5. But we need to also add 5 to the far left and the far right side. So instead of adding 5 just to two parts, to two sides, we have 3 parts to add 5 to. So when you do that, in the middle we have x, on the left we have positive 2, and on the right, negative 1 plus 5 is positive 4. So method 2 is my method of choice, but you're welcome to split it apart as two different statements, as you see in method 1. Next, we're going to talk about absolute value inequalities. So with absolute value inequalities, what we know is that if we have the absolute value of some number that we'll call e, and if it's less than or equal to a, that is true if and only if e is between negative a and a. Now this math notation is maybe a little bit confusing or abstract, but basically with an actual example, what we know is that if we have the absolute value of some variable, and that is less than or equal to, or just less than, some number. We'll just use number 3. What we know is that x is going to be less than or equal to 3, and then x is going to be greater than or equal to negative 3. It's an and statement, which we can actually put together as one statement where x is less than or equal to 3, and it's greater than or equal to negative 3. So basically it's going to be between the negative 3 and positive 3. So instead of going through all the steps of writing it as an and statement with the two parts and then putting it together into one combined inequality, we can just jump right to this part right here, this statement. All right, so that's the idea behind the first property. If it's a greater than symbol, so if the absolute value is greater than a, then we have two parts where e is less than or equal to negative a, or e is greater than or equal to positive a. So what would that look like? Well, if we have the absolute value of x is greater than 7, so it's greater than 7, we have two different parts, two different statements. The first one would be x is greater than 7, and then or x would be less than negative 7. So the second case, we need to flip the inequality and change the sign from positive to negative. And personally, the way I remember this, the difference between knowing if it's an and or an or statement is that the greater than or greater than or equal to symbol, so that is greater. The ER sounds kind of like or, so that's maybe kind of a stretch for you, but greater or greater than is going to be an or statement. And we see that right here. It's got the greater than or equal to symbol. It's going to be or, and then less than is going to be and. So than and sound kind of similar. Less than is and. So whatever helps you remember the difference between and or, that's fine, but make sure you know the difference and when to use each. Let's try some examples. Here we have the absolute value of x minus 2 is less than 8. All right, so first off, this is a less than symbol. So less than is going to be an and statement. All right, so it's going to be an and statement, which we can just jump and write this as a combined inequality, because we know that we have x minus 2 is less than 8, and x minus 2 is greater than negative 8. So you switch the inequality from less than to greater than, and then from positive to negative for the other scenario. All right, so we can write it like this as two different statements, or you can just jump to the fact that x minus 2 is less than 8 and it's greater than negative 8. So you could write it like that. And we see it typed up right here in this manner. This is going to be the quickest way to solve. And what we do is we just solve for x by adding 2 to all three parts of the inequality. That gives you x in the middle, 10 on the right, and then negative 6 on the left. So your answer is that x is between negative 6 and 10. Now if you were to graph this, we can have our number line right here. Here's negative 6, over here is 10. And you just shade in everything between negative 6 and 10. And then right at negative 6, we're going to have a parentheses because it doesn't actually reach negative 6. Okay, it's just less than symbol. So because of that, it's going to be parentheses. And then, I'm sorry, over here on the 10 too, it should be just parentheses. So I don't know why that's a bracket. It should be parentheses over here too. All right, so parentheses at negative 6 and 10 because there's no equal sign with it. All right, so the bracket is used with the equal sign. Parentheses is used without the equal sign. Let's try another example. And here we have a greater than or equal to symbol. So first off, realize that the greater than symbol indicates that we have an or statement. Remember, greater than is going to be an or statement. So what we have is negative 8x minus 3 is greater than or equal to 11. So we just rewrite it. Negative 8x minus 3 is greater than or equal to 11. Or negative 8x minus 3 is less than or equal to negative 11. So you switch the inequality from greater to less than, and from positive 11 to negative 11. Now from here, we can solve each of these inequalities. So the first one, we can add 3 to both sides. And now we have negative 8x is less than or equal to negative 8. And then we can divide both sides by negative 8 to solve for x. When you do that on the left side, negative 8's will cancel. You have x on the left and then positive 1 on the right. And by dividing by a negative, you must switch the inequality from a less than to a greater than. And then the second inequality, we do the same steps where we add 3 to both sides. That gives you negative 8x on the left and then 14 on the right. And then divide both sides by negative 8, just like we did for the first inequality. And now we have x on the left, negative 14 over 8, which can reduce to give you negative 7 over 4. That will be on the right. And then when you divide by the negative sign, you need to switch the inequality from a greater than or equal to a less than or equal to. And again, the connecting word is going to be the word or. All right, so now for graphing purposes, we can take our number line and the right here, the less than or equal to negative 7/4, that's really close to negative 2. That's right before negative 2. So it's going to be a bracket right here at negative 1 3/4, right before negative 2. So bracket, because it's got the equal sign, is going to include that number. And then we shade into the left, because that is where the numbers for x will be less than negative 1 3/4. And then the other part, x is greater than or equal to 1, we can start at 1, and then we shade into the right. And it's going to be, again, a bracket, because it has an equal sign with the statement. So your graph would look like this. So we've learned how to solve absolute value inequalities. Now we're going to work with how to solve polynomial inequalities. All right, so we have a property called the sign property of polynomials. And this says that for all values of x between two consecutive real zeros, all values of x are either all positive or all negative. So we're going to make sense of that here in a moment, but that is important because we're going to need that as we solve different polynomial inequalities. And when we say a polynomial inequality, that will be anything that has an exponent with the variable. So when you're doing this, we first need to find what we call the critical values. So critical values. That's a fancy word for finding the zeros of the inequality. So, or in other words, find the solution, all right? So find the solution for x. But specifically, we need to replace the greater than or equal to symbol with an equal sign and just solve it like you would an equation. And we've learned that in a previous lesson, how to solve equations like this. So you're going to go through and solve this to figure out the zeros of the equation, and the answers that we get to, those are called the critical values. And we're going to use those values to determine the solution, or the interval or intervals in which x will make a true statement. All right, so let's just go through and solve this. This one has 4 terms. All right, so with 4 terms, we're going to want to try factoring by grouping. So what we can do is we can group together the first 2 terms and the last 2 terms. And then when you group the last 2 terms, notice there's a negative on the outside of the parentheses. So that negative is now going to the 2x and the negative 3, which means we need to change the sign here with the 3 to account for that. And then from here, we can pull out the greatest common factor from each of these parentheses. The first one, we have an x squared in common. So you factor an x squared out, and you're left with 2x plus 3. And then the second parentheses is already factored, but there's an assumed 1 out in the front that we're going to want to know that it's there. All right, so you have minus 1 times 2x plus 3. All that is equal to 0. Now from here, notice they both have a 2x plus 3 in common. We can factor that out, and then you're left with, in parentheses, x squared minus 1. So that's x squared minus 1, and that's all equal to 0. All right, and then x squared minus 1 can actually factor further. That would give you x minus 1 times x plus 1. That is a difference of squares. So now to solve this, we set each part equal to 0. So either 2x plus 3 equals 0, x minus 1 equals 0, or x plus 1 equals 0. So you solve each of these to get x equals negative 3 over 2, x equals 1, or x equals negative 1. So your critical values are here, here, and here. Now that's not your answer. We're not done yet, but that is our critical values. So we're going to take those numbers and then we'll use those in a moment. So what we can do from this point is we can draw a number line. All right, so on this number line, we're going to find these three critical values of 1, negative 1, and negative 1.5. And so here is 1, here's negative 1, that's negative 2. So we have our critical values here at 1. So here's a red line going up, negative 1, and then negative 1.5. That was the negative 3 over 2. So what we have is 4 different intervals. We have one here on the far left, one between negative 2 and negative 1. We have one between negative 1 and positive 1. Then we have an interval from 1 to infinity here on the far right. So we have 4 different parts of this number line. Now what we can do is we can look at each of those factors that we had. So right here, where we had 2x plus 3, x plus 1 times x minus 1, let's write those on the side over here. Now this is one approach we can use, but with this approach that we're using, we take a look at each of these factors and determine what the sign is going to be with each of these intervals. So figure out is it going to be positive or negative in each of those 4 locations on this number line. So 2x plus 3, all right, if you think through that, 2x plus 3, where will it be positive and where will it be negative? So what values for x would make that 2x plus 3 positive and where would it be negative? All right, so if you think through this, if you plug in something like negative 1, if you plug in negative 1 in for x, for 2 times negative 1 plus 3, that's going to give you a positive number. So it's going to be positive at negative 1. It's going to be positive even right up until negative 1.5. Anything less than negative 1.5 is going to be negative. So we can put signs here. It's going to be negative to the left, or numbers that are smaller than negative 1.5. Anything bigger than that is going to be positive. And you can experiment, plug in numbers, plug in number 2, for example, over here. 2 times 2 plus 3, that's going to be positive 7. So we put plus signs where it's going to be positive, negative signs where it would be negative. All right, what about x plus 1? What values of x would make x plus 1 positive, and where would it be negative? Well, if you plug in anything bigger than negative 1, say you plug in a 0 or a 1 or a 2, anything bigger than negative 1, x plus 1 is going to be positive. So anything to the right of negative 1 will be positive. Anything less than negative 1 is going to be negative. All right, so we can put the signs here like this. Now what about x minus 1? Well, anything bigger than 1, when you plug it in for x, would make it positive. Anything less than 1 would be negative. So like if you plugged in a 0 for x, 0 minus 1 would be negative 1. So it's going to be a negative number when you plug a 0 in, and when you plug in anything less than 1. All right, so we're using that sign property of inequalities to create this. So from here, you now need to think through that when you multiply these 3 factors together, so the 2x plus 3, x plus 1, x minus 1, at what point or within which intervals will that product be bigger than 0? Or in other words, when will it be positive? Right? If it's greater than or equal to 0, that means it's got to be a positive number, right? So where will the product be positive? Well, that's going to be when you have an even number of negative numbers. right? So like here in this interval on the far left, where you have the 3 negatives, all right, that would be negative when you multiply together, because if you have 3 negatives multiplied together, that would be negative. It's going to be less than 0. So the far left interval does not work. This next interval between -1.5 and -1 would work, because notice we have 2 negatives multiplied together from the x plus 1 and x minus 1. So the 2 negatives would make a positive number. So this interval between -2 and -1 would work. It would be bigger or equal than 0. The next interval between -1 and 1 would not work, because we have 1 negative multiplied by 2 positive numbers, and that would not be positive. It would be a negative answer. So that would not work. And the far right side would work. Over here from 1 to infinity, that would work, because we have 3 positive numbers multiplied together, and that would give you a positive number. That would be bigger than 0. So we have 2 different intervals that would work. Okay, so we have between the -1.5 and -1. So that would work on the number line. Or from +1 all the way to infinity. So from 1 to infinity would also work. All right, so your graph would look like this, and your answer would be those intervals. So if you write it in interval notation, it would look like this. So we have from -3.5 to -1. That's what this means right here. -3.5 to -1. Union, or, is combined with the other. Or is from 1 all the way to infinity. So it's going to be written out like this. So make sure you can get to the graph and also get to your solution written in interval notation, or you can write it in set builder notation if that's what the directions ask for. Now that is one approach you can use to finding your solution, your final answer. There's another approach you could use, is when you factor right here and you find the critical values. You can still think through the number line and put your critical values here. But another approach of doing this is you can plug in a number that falls within a certain interval, within each of these intervals, and see would it give you a true answer when you plug it in. All right, so you can, for example, take a number that is less than the -1.5 right here. Let's say you plug in a -2. So you could plug a -2 in and see what happens to the inequality. So it's going to be really tedious. So you can plug a -2 in. That's going to be your test value. So you plug a -2 in, what you're going to find is that you get a false statement. And you can verify that if you want. It's going to be time consuming and tedious. But if you plug a -2 in, it's going to be a false statement. You have some number that's actually not bigger than 0, but it's going to say that it is. It's going to be false. And then you can plug in something between -1 and -1.5 for this other interval. So it doesn't work for this interval, but if you plugged in, let's say, like -1.25. So you plug in -1.25, something within the second interval, you can plug it in for x and go through all the work, all the steps of solving. If it becomes a true statement, then it's going to work in that interval. And that's what you're going to find. It's going to be true for that interval. It's going to hold true. So it's going to work for that part. And then you can plug in a test value in this third interval. It'd be easiest if you plug a 0 in. So if you plug a 0 in for x from this interval, plug it in, you get 0 plus 0 minus 3. So you have -3 is greater than or equal to 0. That is false. So it's not going to work for that interval right here. And then we can do the final interval on the far right side. We can pick a test value. So let's pick something bigger than 1. You plug a 2 in, for example. If you plug a 2 in for x up here, you're going to get a true statement. And you can verify that, plug it in, you'll prove that that's true. So it's going to work in that interval. So that's another way you can do it. It's going to be very tedious, more tedious than the other method we showed you, but you're allowed to do that. So you have to find the critical values still. So you go through all these steps to find the critical values, and then pick a test value within each of those different ranges, in each of those different intervals, and see, is it going to, when you plug it in, will it be a true statement or a false statement? If it's true, that means it works, and that means that interval is true. It's going to work, numbers are going to work within that interval. So again, it's more tedious, but you are allowed to do this. Next, we have rational inequalities. So this would be something where you have a fraction of some sort, and then some inequality with the fraction. All right, so when you're doing this, say, for example, you had x minus 4 over x plus 3 is greater than or equal to 6. What you need to do is write the inequality, so one side is a rational expression, and the other side is 0. All right, so meaning if this were your problem, you have to bring the 6 to the left side first. So set it equal, or have it 0 on the one side. And then from there, we can find the real zeros of the numerator and the denominator of the rational expression. So we'd have to make sure we have just one fraction on the left side, and then whatever those zeros are, those are your critical values. And then from there, we can go through that process we just went through to determine which intervals will work for solutions. So here is our example. We have 3 over x minus 2 is less than -1. Now remember, first thing is we need to have 0 on the one side and a fraction on the other side. So let's bring this -1 to the left by adding 1 to both sides. When you do that, we're now going to have 0 on the right, and then 3 over x minus 2 plus 1 on the left. Now from here, we need to write this left side as a single fraction. So we need to take what we have, and then we need to find a common denominator. So see the 1? We need to take the 1 and multiply the top, multiply 1 by x minus 2, and then also divide by x minus 2. And the reason is because that gives us a common denominator, and that's the same thing as multiplying by 1. It doesn't change the value of the number we started with, but it just makes this into a different form. So now from here, we can combine into a single fraction. We have a common denominator of x minus 2. We can put the numerators together. We would have 3 plus 1x, and then plus 1 times -2, which is -2. So we have 3 plus x minus 2 in the numerator, and that's less than 0. And then on the top, 3 minus 2 is 1, so we have 1 plus x over x minus 2, and that is less than 0. And we see that all typed up right here. So now at this point, once we have it in this format, where we have a fraction on the left side and then 0 on the right side, we can now find the critical values by looking at the numerator and the denominator. So we can set the numerator and denominator equal to 0. The numerator is x plus 1 equals 0. Denominator would be x minus 2 equals 0. So set each part equal to 0 and then solve. Here we get x equals -1. Here x would equal +2. So -1 and +2 are the critical values. So from here, we can use our number line and then find the values of -1 and +2 and use that to create our different intervals. So here we see that we have 3 parts. We have the far left, so numbers less than -1. We have the middle between -1 and 2, and the far right, which would be greater than 2. So from here, what we can do is we can take those factors of x plus 1 and x minus 2 and determine the signs of each of those within each of the different intervals. So for example, with x plus 1, actually let's do x minus 2 first. With x minus 2, where will x minus 2 be positive and where will it be negative? So for what values of x would it be positive or negative? Well, if you plug in anything bigger than 2 for x minus 2, so if you plug in like 3 or 4 or 5, anything bigger than 2, it's going to be positive. So we see that here. Anything to the right of 2 is positive. Anything less than 2 is going to be negative. And then for x plus 1, where will the signs be positive and where will the signs be negative? Well, if you plug in anything bigger than negative 1, say you plug in a 0, a 1, a 2, a 3, etc., anything bigger than negative 1 is going to make x plus 1 positive. So anything to the right of negative 1 is positive. Anything to the left of negative 1 would be negative. So now from here, we need to look at this expression. So look right here. When we divide, we want our answer to be less than 0. Or in other words, we want it to be negative. So the question is, within which intervals will we have a negative answer? Well, keep in mind that we are dividing. We're dividing two different numbers, right? So where it's going to be less than 0 is going to be when you have like a positive and negative divided by each other. So like here on the far left, we have two negatives. If you divide two negatives, all right, that's not going to work. That's going to be a positive number. That's going to be bigger than 0. If we have two positives, like on the far right, that's not going to work because that's going to be, again, positive. But if you have a positive divided by a negative, that will be less than 0. It's going to be negative. So this middle interval will work. So your answer is going to be between negative 1 and positive 2. So it's between negative 1 and positive 2. So when you graph, it's going to look like this. And if you write your answer in interval notation, you write it with parentheses. So parentheses, negative 1, comma, 2. All right, that means it's going to go from negative 1 to positive 2. Now, one thing to be aware of is what if this were a less than or equal to sign? All right, so it's pretty similar, but typically you'd put brackets instead of parentheses, right? So you can put brackets around negative 1, brackets around the 2, but be careful because it's actually not 100% correct. The reason is because if you look at the denominator, x minus 2, okay, x cannot equal 2. The reason is because if x is equal to 2, it's going to be 0 in the denominator, making this whole fraction undefined. So x cannot equal 2. So what that means is that here at 2, we actually cannot use a bracket. We have to use a parentheses because the parentheses indicates that it will not actually equal 2, but it's going to get infinitely close to 2. All right, so the bracket indicates that it could equal 2. Parentheses means that it cannot equal 2. All right, so if you had an equal sign here, just be careful that in this case, we'd put a bracket at the negative 1 and parentheses over here at positive 2. Now to finish off this lesson, we are going to work with applications of inequalities. So here is a word problem. And we're told that William's pickup truck gets between 18 and 22 miles per gallon of gasoline. His gas tank can hold 15 gallons of gas. And if he drives at an average speed of 40 miles per hour, how much driving time does he get on a full tank of gas? So to begin with, we can establish our variable. And the question is, how much driving time does he get on a full tank of gas? So we can let driving time will equal x. That is your unknown. All right, so driving time is going to be x. And from here, we can figure out his total miles traveled. All right, his total miles traveled is determined by looking at his speed. So if he travels at 40 miles per hour for x amount of hours, his total miles would be 40 times x. All right, and then the last part would be miles per gallon. So miles per gallon. So what we can do is we can take his total miles of 40x and then divide by 15 because there's 15 gallons of gas that his tank can hold. That would be his miles per gallon, 40x over 15. And we see that all typed up right here. All right, and then here at the beginning it says his pickup truck gets between 18 and 22 miles per gallon. So we can take this 40x over 15 and write it as an inequality. So it's between 18 and 22. So we can write this as a combined inequality where we have 18 is less than or equal to 40x over 15 is less than or equal to 22. And then from here we can solve this inequality. So once you have the setup, that's the hard part, we can then use our information of how to solve inequalities to then figure out your answer. So from here we can get rid of the 15 by multiplying every part by 15. So when you do that, you have 40x in the middle, 18 times 15 would be 270 on the left, and then 22 times 15 would be 330 on the right. And then to finish off, you can divide everything by 40 to get x by itself. So when you do that, you have x in the middle, you have 6.75 on the left, and 8.25 on the right. So x was his driving time. So that means he can drive between 6 3/4 of an hour and 8 1/4 of an hour, which would be 6 hours and 45 minutes and 8 hours and 15 minutes. All right, so that would be your answer. He can drive between those amount of times. And that concludes our